This is the final problem for the mass and Newton's laws set. And in this problem, we're going to be combining all of Newton's laws to work through one final problem. So in this example, imagine there's a boat. And a boat with propellers works by propelling the water backwards to make itself go forwards, following Newton's third law. So let's say the propeller on this boat is capable of exerting a force on 100 kilograms of water. At what acceleration does this water need to undergo in order to make this 1,000-kilogram boat move at a constant velocity, assuming that there's 500 newtons of drag due to the resistance on the water? So I've given you all of the information you need to work out this problem. Use all of Newton's three laws to figure this out. Pause the video, and we'll go through it together. So we need to start with looking at the force the boat exerts on the water. And we're going to call the acceleration that the water experiences acceleration A. And we know that force equals mass times acceleration. So the force equals 100 kilograms, that's the mass of the water, times the acceleration. And by Newton's first law, we know that the net acceleration is zero, the velocity is constant, so the net force must also be zero. Therefore, since the only other force is a backwards force of 500 newtons, the force being exerted on the water must also be backwards 500 newtons, because the force of the thrust needs to exert an equal and opposite reaction that is forward 500 newtons. So looking at this, we know that 500 newtons, actually negative 500 newtons, because the force on the water over here is in the negative direction, equals 100 kilograms times acceleration. So acceleration equals negative 5 meters per second squared. And this is true because, once again, a newton is 1 kilogram meter per second squared. And so dividing newtons by kilograms gives 1 meter per second squared. So now let's take this problem one step farther. Let's say we want the boat to accelerate at 2 meters per second. Now, for comparison, 2 meters per second squared is 1/5 of the acceleration of gravity, or also 0.2 g's. You've probably heard that term also. So for this scenario, you have to figure out what is the acceleration that the water is undergoing coming out of the propeller in order that the boat itself accelerates forward at 2 meters per second squared. So once again, pause the video, take a little time to do this, and then we'll go over it together. This time, we have to start with Newton's second law. We know that force equals mass times acceleration. We know that the acceleration of the boat is 2 meters per second, and that the mass of the boat is 1,000 kilograms. So force equals 1,000 kilograms times 2 meters per second squared, or 2,000, one too many zeros, 2,000 newtons. That's the force, the net force that has to be exerted forwards. So now we look at all the forces on the boat. We'll draw a free body diagram. So if this is our miniaturized version of the boat, this is the force backwards on the water. We'll call it F sub W, which creates an equal but opposite force forward. We'll call that F sub B for the force on the boat. And there's a force of friction backwards. Now the force of water isn't actually being exerted on the boat, it's on a different object. Because if you remember, Newton's third law exerts on different objects, so we can ignore this one. So the force on the boat plus the force of friction equals 2,000 newtons by our calculations. Now we know the force of friction is 500 newtons, but backwards, so we can say that the force on the boat minus 500 newtons equals 2,000 newtons. So now solving for that, we add 500 newtons to both sides, and the force on the boat equals 2,500 newtons. Since it's equal and opposite, this must be the same force that's being exerted on the water. Now, because the water is in the opposite direction, that's negative 2,500 newtons, and the mass is 100 kilograms. So now we're finally ready to find out the acceleration. Going back to F equals ma, and I'm sure you're sick of me saying that by this point, but it's one of the fundamental units of physics, so we're going to use it again. Negative 2,500 newtons equals 100 kilograms times whatever the acceleration happens to be. We divide through by 100 kilograms on each side. Do the arithmetic, and we end up with negative 25 meters per second squared equals acceleration. We do a check. Meters per second squared is the unit for acceleration, so the units check out. It's negative, so it's in the negative direction, and that's good because the water is being forced backwards. So we can conclude that we probably did it right. And the acceleration of the water is negative 25 meters per second squared. And if the propellers can achieve that level of acceleration with 100 kilograms of water, that'll be enough to move the boat forward at 2 meters per second squared. So sorry this has been a little bit of a long video. Hopefully you understood what was going on here. If you didn't, take a second, look back, and if you did, then you've successfully grasped all the concepts from mass and Newton's laws.